So in this video, we're going to see a data structures 2 marks question from the year GATE 2013, and it's based on the topic of binary search tree. So let's see what the question is. The pre-order traversal sequence of a binary search tree is, and this is the pre-order traversal sequence of a binary search tree. Let's make a note of that. It's not a binary tree, it's a binary search tree. Okay. Now, which one of the following is the post-order traversal sequence of the same tree? So out of these 4 options, one of them is the post-order traversal of the same tree. Now, before we move ahead, let's quickly see what is a pre-order traversal of a tree. So let me just write it down here. Pre-order traversal. Okay, so consider this binary tree plus as its root and A and B as its children. So the pre-order traversal of this tree is plus A, B. This is how the tree will be traveled. Now the point to be noted here is, first we will visit the root, okay, then we visit the left, and then we visit the right. Okay, this is how a pre-order traversal of a tree happens. Okay, now let me note down this pre-order traversal of the given tree. So let me just note down here 30, 20, 10, 15, 25, 23, 39, 35 and 42. Yes, so this is my pre-order traversal of the tree. Now let's focus on how the pre-order traversal happens. As we have mentioned here, first the root is visited, then to the left and then to the right. It means that whenever we are going to have a pre-order traversal sequence, the first value in our sequence is going to be the root. Okay, the first value of the sequence is always going to be the root. So it is very safe to assume that in this entire pre-order traversal sequence, 30 is the root of our binary search tree. So let's make a note of that. Yes, so 30 is going to be the root of my binary search tree. Now since it's a binary search tree, we all know the important property of binary search tree, that everything to its left is going to be less than and everything to its right is going to be greater than. So everything to the left of 30 is going to be less than 30 and everything to the right of 30 is going to be greater than 30. So let's rewrite our sequence now. Now since 30 has become the root, 30 is out of competition. What we have is 20, 10, 15, 25, 23. These are all going to be to its left, and greater than 30 we have 39, 35 and 42. These are all going to be to our right. Now again, let's focus on this left subtree. Now left subtree is also going to follow a pre-order traversal. So again, applying the same property, in pre-order traversal the first thing we visit is the root. So in this pre-order traversal, the first value is also going to be the root. So 20 is going to be the root. I'm going to mark it again as the root here, and everything to the left is going to be less than 20, everything to the right is going to be greater than 20. So let's make a note of that. 10 and 15 and okay, greater than this we have 25 and 23. Note the sequence in which I'm writing the subtree is the same as it was in the previous sequence. So here if we have 10 and 15 in that sequence, we write it in the same sequence. If we have 25, 23, then we write 25, 23. Don't write 23, 25 because then you are messing up the sequence. The first value of any sequence is always the root. So 20 will remain the root here. Now, again in this sequence you can see 10 is the first value. So it is going to be, it's a pre-order traversal, it is going to be the root. So let's make a note of that. Let me use another color here. So 10 is going to be the root here. Now there is nothing small than 10. So its left subtree is going to be null, and 15 is greater. So I'm going to make 15 like this. Now here again same, 25 is going to be my root. So 25 becomes the root, and small than 25 we have only 23, and there is nothing greater than 25. So that's going to be null. So this way I'm completed my left subtree. Similarly, I'm going to complete my right subtree. Very much equal. 39 is the first value in the pre-order traversal. So 39 is going to be the root. So let's quickly make it the root. So 39 becomes my root. Now everything less than 39 is to the left. So there's only one value, which is 35. And there's only one value greater than 39, which is 42. So thus Here we have taken a pre-order traversal of a binary search tree, not a binary tree, and we have applied all the properties of a pre-order traversal as well as binary search tree, and we have constructed the original tree. So let's write the original binary search tree in a very nice way. So here it is. We have 30 at the root, and then from 30 we have 20 and 39, and then from 20 we have 10 and 25, and from 39 we have 35 and 42, and further from 10 this is null, we have here 15, and this is 23, and we have this as null. Yes, so this becomes my, let me do a mark here. Okay, so this is my original binary search tree. Now once we have original binary search tree, the question had asked for the post order traversal of the tree. So let's do a post order traversal of this tree. And before we go into actually coming out with the post order traversal, let's quickly revise what is post order traversal. So this is my post order traversal. Okay, so again the same example, if this is plus and A and B, okay, if this is my tree, then its post order traversal is A, B and plus. Okay, this is the post order traversal of it. Now the thing we have to note here again is this, the first we visit to left, okay, then we visit to the right, and finally we visit to the root. Okay, so the sequence of post order traversal is left, right, root. At the end we visit the root. So again, now we are going to apply this sequence to our binary search tree. This is the binary search tree which we have got, and then let's see what comes the post order traversal. That is going to be our answer. So let's go. Yes, so this is my root here. I'm going to start from here. Step 1, I'm at the root. Now the post order traversal says we have to first go to the left, so let's keep on going to the left. So this is, sorry, so this come to the left, second point, come to the left, this is my third iteration, and left of 10 is null. So then left iteration is over, then we go to the right. So we come to the right here, so this becomes my fourth iteration. Now once we are at node number 15, left is null, its right is also null. So finally the root is visited, so 15 is visited, oops, and then 15 will be the first value in my sequence. Okay, 15 will be the first node in the sequence. Now once this is completed, we track back and we go to this node, now 10. So now if you focus on 10, its left is visited, its right is also visited. So left is done, right is done, so root is remaining. So 10 will get printed, so 10 gets printed here. Now once 10 is visited, we again backtrack, we go where we were before, so we were at this position 2. Now if you focus on the node 20, its left is visited, the left subtree of 20 is visited. Now next step is right, so we go to right again, so we'll come here, which will be 5, and then from this node again first we go to the left, so then this will be 6. Okay, and once we are at node number 23, there is nothing to the left, there is nothing to the right, so we will now print the root, which is 23. So okay, so 23 is also done, and then 23 is gone. Then we'll again backtrack, we come to 25, and at 25, now again if you focus on 25, its left is visited, its right is also visited, so 25 is the one which will get printed. So 25 will come here, and then this is also gone, and then we come again back to 20. Now if you focus on 20, its left is visited, its right is visited, so 20 is the root remaining, 20 will get printed, and this way we write 20 here. And then once this is also done, we now come to the root node, and now from the root node we will go to its right. The left of root is done, now we'll go to the right. But before we go into the right, let's quickly have a look at the option. It's possible that one of the options will have, only one option will have this as its sequence in the beginning, so we can directly mark it as the right option. So let me zoom out here. Okay, 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 let's zoom out completely. So as you can see, this at the extreme bottom is my okay, at the extreme bottom is my post order sequence. It's not complete. 15, 10, 23, 25. So 15, 10, 23, 25. Only one option fortunately has this correct sequence, so we can directly mark that option as our right answer. So option D is going to be my right answer.